In this video, we are going to learn how to write chemical formula when we have complex or group ions. At National 5 level, you are not expected to remember the most common group ions, and so these are given to you on page 8 of your SQA data book. When writing formula for compounds containing complex ions, we need to use the valency rules. Remember, the valency rules are: first you write the symbol, then the valency, then you swap your valencies, divide them if possible, in order to write your formula correctly. The valency of main group elements comes from the number of unpaired outer electrons they have. However, the valency of these ions, so for complex ions, is given by the magnitude, i.e. the number, of the charge. For example, when we have an hydroxide ion, our charge is 1 negative charge, therefore our valency is 1. Using that information, let us work through some examples together. So here we have, for our first one, we have lithium hydroxide. The very first thing to do is write down your valency rules at the side. Symbol, valency, swap, divide and formula. And now fill in the symbols for our elements. So lithium is in group 1, symbol is Li. Hydroxide is a group ion, so you go to page 8 of your data booklet, you look at the table at the very top and you'll see that hydroxide has the symbol OH minus. Lithium is in group 1, it has 1 unpaired electron, so it's a valency of 1. Hydroxide has a 1 negative charge, so it has a valency of 1. Remember, charge equals valency. We then swap these, can't divide them, and we get lithium hydroxide for our formula. If you're not asked to provide the ionic formula, then you do not need to put the charges in the final step. Let's have a look at rubidium phosphate. Again, symbol, valency, swap, divide and formula. The symbol for rubidium is Rb. Symbol for phosphate, we have PO4 and it is a 3 negative ion. Rubidium is in group 1, it's an alkali metal, so it has a valency of 1. Our phosphate ion has a 3 minus charge, therefore it has a valency of 3. We swap these over, can't divide them, so our formula is Rb3PO4, and we could put the 1 in, but remember the fact that we've written it means that there's already 1 present, so we can just write this as Rb3PO4. Let's move on to our third example. Symbol for copper is Cu. It's a Roman numeral, so we have been given the valency for it, so we know the valency is 2. Sulfate, it is a group ion, so looking at page 8 we see its formula is SO4 and it is a 2 minus. Charge equals valency, so the 2 comes down here. We swap them over. We can divide this time, we can divide them both by 2. 2 divided by 2 is 1. And for our formula we write our top line and our bottom line. And again, the element symbol means that there's at least 1 in there, so we can remove that and rewrite as let's have a look at example 4, potassium permanganate. Symbol for potassium is K. It is in group 1, the alkali metals. It has 1 unpaired outer electron, so a valency of 1. Permanganate, it's a complex ion. You'll find the formula on page 8. It's MnO4 minus. Charge of 1, valency of 1. Swap them. Can't divide them. Our formula is KMnO4. Let's now move on and have a look at example 5. Here we have radium chromate. The symbol for radium is Ra. It is in group 2 and has a valency of 2. Chromate ion is CrO4 2-. Charge of 2, valency of 2. Oh, we swap them. We can divide them. And so our formula is RaCrO4. And now for our last one. This one is a bit more difficult for the simple fact that here we have 2 complex ions. So we have ammonium, which at National 5 is actually the only positive ion you need to know. And we have our nitrate ion. And again, both of these are found on page 8 of your data booklet. Remember that the charge equals the valency, so 1 positive charge is a valency of 1, and a 1 negative charge is a valency of 1. Swap them, can't divide them. So here our formula is NH4NO3.